Hello students, I am Soumya Sahu, lecturer in Civil Engineering at SKDB Government Polytechnic Rourkela, and this video lecture is prepared for the third semester Diploma Civil Engineering students. In today's lecture video, we shall discuss about mortar, sand and some other building materials. Mortars are usually named according to the binding material used in their preparation. And they are essentially required for masonry work, plastering and pointing. Functions of mortar: to bind together the bricks or stones properly and to provide strength to the structure, mortar is used. To form a homogeneous mass of the structure so as to resist all the load coming over it without disintegration is another function of mortar. Then next is the composition of mortar. Modern mortars are typically made from a mixture of sand, a binder such as cement or lime, and water. Here you can see mortar is prepared with 1:3 proportion of cement and sand, and about 3/4 of water is added, and this mixture is then prepared. An ideal mortar should adhere completely and durably to all the masonry unit to provide stability, and it remains workable long enough to enable the operative to set the masonry unit right to the line and level. This implies good water retentivity. It stiffens sufficiently quickly to permit the laying of the units to proceed smoothly and provides rapid development of strength and adequate strength when hardened. An ideal mortar is resistant to the action of environmental factors such as frost and abrasion and destructive effects of chemical salts such as sulfate attack. It resists the penetration of rain. It accommodates movement of the structure. It accommodates irregularities in size of masonry units. It contributes to the overall aesthetic appearance. It is cost effective. So mortar is used as a binding material, plastering work, pointing work, masonry joints are done with the help of mortar. Different types of mortars. So mortars are classified on the basis of the following: bulk density, kind of binding material, nature of application and spatial requirements. Depending upon the bulk density, there are two types of mortars. First one is heavy mortar and second one is lightweight mortar. So heavy mortar is having bulk density greater than or equal to 1500 kg per meter cube, and lightweight mortar is having bulk density less than 1500 kg per meter cube. Depending upon the kind of binding material, there are four types of mortar: lime surki mortar, mud mortar and cement mortar. So lime mortar is a type of mortar composed of lime and an aggregate such as sand mixed with water. A lime kiln is used to produce quick lime through the calcination of limestone. So here you can see the reaction. So if calcium carbonate is heated, then calcium oxide and carbon dioxide is formed. So calcium oxide, commonly known as quicklime or burnt lime, is widely used chemical compound. It is a white caustic alkaline crystalline solid at room temperature, usually obtained from limestone. Slaking of lime. When water is added to quicklime in sufficient quantity, lime cracks, swells and falls into powder form due to the chemical reaction, thus forming calcium hydrate. This is known as the slaking of lime. Next one is mud mortar. The paste is prepared by mixing suitable clay soil with water. The soil which is used for preparation of mud mortar should be free from grass and pebbles, and these are the cheapest mortars but weakest in strength. These mortars are used for brickwork of ordinary buildings and for plastering walls in rural areas. In the slide, you can see the figure of a mud wall. Next one is cement mortar. The paste is prepared by mixing cement and sand in suitable proportion in addition to water. The general proportion is 1 part of cement to 2 to 8 parts of clean sand. These mortars must be used within half an hour, that is before initial setting time of the cement. This type is used for all engineering works where high strength is desired, such as load-bearing walls, deep foundation and flooring. Mixing by hand, the sands and cements are heaped up on a mixing board or in a wheelbarrow and repeatedly turned over and over until thoroughly mixed. The color of the dry mix will change as the cement is distributed throughout. There should be no streaking of cement and no clumps of pure sand or pure cement. Once the dry ingredients are mixed, the water can be added. When using a mechanical mixture, add half a bucket of clean cold water to the empty drum before adding the dry ingredients in sequence. Add 4 measures of sand, then 1 of cement, followed by 4 sand, then another cement, and so on until the required quantity is in the mixture. This ensures a more thorough mix than adding say 20 measures of sand and then 5 measures of cement. Again, the water is added to the revolving drum once the dry ingredients are thoroughly blended, a bit at a time until the required consistency is achieved. Special type of mortars: fire resistant mortar, lightweight mortar, packing mortar, sound absorbing mortar and X-ray shielding mortar. So fire resistant mortar is a paste prepared by mixing aluminous cement and finely crushed fire bricks in 1:2 proportion in addition to water. The usual proportion are 1 part of aluminous cement to 2 parts of finely crushed fire bricks. These are generally used for lining furnaces, ovens and fireplaces with fire bricks. Lightweight mortar: the paste is prepared by mixing wood powder, wood sawing or sawdust with cement or lime mortar. In such mortars, fibers of jute, core or asbestos fiber can also be used. These are generally used as fiber plasters in sound and heat-proof construction. Then next we shall discuss about sand. So sand is a naturally occurring granular material composed of finely divided rock and mineral particles. The most common constituent of sand is silica or silicon dioxide, and its symbol is written here, SiO2. This is usually in the form of quartz. Sources of sand: sand is formed by the weathering of rocks based on the natural sources from which sand is obtained. It is classified into pit sand, river sand and sea sand. Pit sand: this sand is obtained by forming pits in soil. It is excavated from a depth of about 1 to 2 meters from the ground level. This sand is found as deposits in soil and it consists of sharp angular grains which are free from salts. It serves as an excellent material for mortar or concrete work, and pit sand must be made free from clay and other organic materials before it can be used in mortar. Coating of oxide of iron over the sand grains should be removed. River sand: this sand is widely used for all purposes. It is obtained from the banks or beds of river and it consists of fine rounded grains. The presence of fine grounded grains is due to mutual attrition under the action of water current. River sand is available in clean conditions. The river sand is almost white in color. The next one is sea sand. This is obtained from sea source. It is brown in color and it also has the fine rounded grain. Sea sand, as it is obtained from sea, it contains salt, which is used in attracting moisture from atmosphere. Such absorption causes dampness and disintegration of work. It is generally not used for engineering purpose. It is generally not used for engineering purposes due to it retards setting action of cement. Then sands are classified based on the grain size distribution: fine sand, coarse sand and gravelly sand. Fine sand is the sand passing through a sieve with a clear opening 1.5875 mm, and fine sand is mainly used for plastering. Coarse sand is the sand passing through a sieve with clear opening of 3.175 mm, and it is generally used for masonry work. Gravelly sand is the sand passing through the sieve with clear opening of 7.62 mm, and it is generally used for concrete work. Then bulking of sand, from your exam point of view, this is very important. The increase in the volume of sand due to the presence of moisture is known as bulking of sand, and this is due to the fact that the moisture forms a film of water around the sand particles, and this results in an increase in the volume of sand. The extent of bulking depends upon the grading of sand. The finer the material, the more will be the increase in volume. For a moisture content of 5 to 8%, the increase in volume may be about 20 to 40% depending upon the gradation of sand. When the moisture content is further increased, the sand particles pack near each other and the amount of bulking is decreased. Hence, dry sand and sand completely flooded with water have the same amount of volume. In order to have a better idea about bulking of sand, let's watch a video.
Bulking of sand. This video deals with bulking of sand. The increase of sand volume due to the presence of moisture is called as bulking of sand. This is due to the formation of a film of water around sand particles, which results in the increase in the sand volume. The extent of sand bulking depends on the grading of sand. The finer sand possesses more bulking than the medium and coarse sand. This is expressed in the graph shown on the screen. For the moisture content of 5 to 8%, the increase in Indiana volume will be around 20 to 40% depending on the grading of sand. The increased moisture content packs the sand particle closer and reduces the bulking. Thus, the dry sand and fully saturated sand have the same volume. The volumetric proportioning of sand is generally affected by bulking of sand. This bulking of sand is high for fine sand and low for coarse sand. If proper measures are not made for the bulking of sand, results in increased cost of concrete and mortar, and also results in undersanded mixes which are harsh and difficulty in working and placing.
Then next we shall discuss about the use of gravel. Crushed gravels are used in ready-mix concrete and round gravels are used in roofing decorating purposes. The use of morrum. Morrum is used as paving material in the construction of road. It is used as basement material in drains. It is used for filling underground tanks. It is used for underlaying surface of foundation. It is used for flooring purposes in buildings. Use of fly ash. It is used as an admixture in concrete. It also improves the strength of concrete. It improves the water tightness of concrete, and it permits the easier placing and finishing of concrete. And fly ash is also used for manufacturing the building bricks. Some of the probable questions that you may get in the examination from this portion are: state and explain the phenomenon of bulking of sand, and state and explain the types of mortar. So thank you students. If you have got any doubts, you can ask me.